Good morning, students. My name is Moyumi Mukherjee and I am your subject teacher of this subject. Before go through the subject, I would introduce the overall course of this subject. This is your syllabus and you can see here that the total syllabus comprises with 5 modules. In the first module, you will be familiar with the fundamentals of signal and system analysis and different types of signals with their nature, focusing on representations of discrete time and continuous time signals. Then you will know linear time invariant, that is LTI system, Fourier representation, Laplace and Z transform with their different equations, block diagram, system function and signal processing as you are covering the modules day by day. Lastly, you will understand the sampling theorem and its implementation. This is your first class of the subject name Signal and System. The code is EC303. In this lecture, I will introduce the concept of signal and system and how they are related to each other. So, what is a signal? A signal is a dependent variable, or we can say it is a function which depends on one or more independent variable. Let's say x1 and x2 are two independent variables and f is a function of these two independent variables. So here f of x1 comma x2 is a signal. Now we talk about difference between a signal and a DC value. Any quantity is said to be signal if it is varying with independent variable, and anything which is constant is not a signal. For example, an alternating current or a AC current is a signal. If we plot an AC current in a graph, the figures will look like this way. In the x-axis is represented for the independent variable, which is here time t, and the y-axis represents the signal itself. In this figure, you can easily see that the AC current is flowing in this way, in a continuous way with respect to time. Therefore, it is a signal. Compared to this figure, if we plot a DC signal or DC current, the figure will look like this. In this figure, we can easily see that the quantity xt is not changing with time. Rather, it is a fixed value, and hence it is not a signal. It is not a signal. So, when we want to frame out the definition of signal, we need to keep in mind three important points. The first one is the signal is time varying, or it is changing with time. Secondly, it is a physical phenomena, or it is a physically occurred. And thirdly, the intention of a signal is to convey some information. Example of various kind of signals are voice signals, video signals, electrical signals, etc. Obviously, each signal carries some information. Now there are two types of signal. One is single variable signal. And second is multivariable signal. A single variable signal, as the name suggests, depends on only one variable, one independent variable, which is here x, and the signal is represented by this way. In case of multivariable signal, depends on two or more independent variable. Here, for example, we are taking two independent variable and the signal is represented by this way. Now, I will talk about system. The meaningful interconnection among a group of a device and component is known as system. But system cannot achieve anything without a signal. Let's represent a system by a rectangular box. This is a system, but it cannot achieve any task alone. For example, we want to fill up a water tank by using a pump. So, this is a pump. Here, it is a pump. And it is a water tank. In this case, pump is a system, but it cannot be able to fill up the tank by water unless it is linked with a signal. And in this case, signal is the electricity. We provide electricity so that pump will perform its operation. So, signal is the electricity. By providing electricity, the pump will perform its operation, that is, it can fill up the tank by using water. So that after receiving signal, system must process with this signal to produce another signal, which is more desirable to the previous one. For example, in case of pump and water tank, after receiving the electricity, pump will produce a mechanical work or a mechanical force so that the water is flowing towards the tank. Hence, here electrical signal is converted into the mechanical signal. So, every system must have a input signal and it produces a output signal which is more desirable than the input signal. The input and output signal both are dependent with the same independent variable. For example, if a system has an input signal f of x1, x2, then it must have an output signal or it produces the output signal which is also represented by this. A system may have n number of input signal and output signal. For example, it is a system. There are n number of input signal and there are n number of output signal. The input of the system is also known as excitation and the output of the system is also known as response. Again, consider a communication system. A communication system consists of transmitter, receiver, channel and many other devices. So, we can say connection between the devices will produce a communication system to transfer the information with the help of signal from one point to another. So, the operation is here the communication. So, we can define a system as a group of interrelated or interconnected entities influenced by a signal that perform any operation. Now there are two types of problem we have to deal with. The first one is analysis type of problem, and the second one is synthesis type of problem. In case of analysis problem, we provide input signal, we have a system, but we don't have output signal. Again repeating, an analysis type of problem has an input signal, there is a system, but we don't have any output signal, or we have to find out the output signal. In case of synthesis type of problem, we have input signal, we have also output signal, but we don't have any system. So there are input signal, there is output signal, but we have to find out system, or there is no system. We have to find out this system with the help of information provided by input signal and output signal. So if we compare these two type of problem, the analysis type of problem is more simpler or more easy to find out the solution, and moreover it's have a exact solution also. But in case of synthesis problem, the type of problem is very complicated with respect to analysis problem. Sometimes we don't get any solution also. This is all for this lecture. If you have any query, you may ask in the Google Classroom comment box. In the next class, we will discuss about the type or classification of signal. Thank you.